Good day everyone, and welcome back to my channel. Today we will be discussing on the relay protection relay setting calculation for medium voltage outgoing cable feeder. So our subject relays are being installed on this area from here, from the outgoing feeder of our 11 kV switchgear, which is installed at building A. So but this will be the same setting to the incomers of our 11 kV switchgear at building F. So meaning our calculation will be for the 4 relays at the building A and at the building F. So here I will show you on the key single line diagram where we can find these feeders. So our subject relays are installed on this breaker from here, and this is for the bus A and for the other bus in this one. Okay, so this will be the same protection relay setting also for the incomers of building F at the bus A and also at the bus B. So earlier we have discussed on our first video the relay setting calculation for the bus coupler of building F. So right now we have actually 4 sources. The 2 sources coming from building A, this one, and the other sources will be coming from building B through this cross tie connection from here, from building A going to, so this will be our main 11 kV switchgear at building B. So through this cable we call this as cross tie between our building B and our building A. So in building B also we have here another 2 power sources. So meaning our building F is being supplied by 4 power sources. So it's the design is really rigid or really robust on this type of power system. So I'll open right now our summary of our relay setting calculation, wherein you can find here the result from our calculation. The relays covered here is for the time over current, the phase element and ground element, and also for the directional over current relay, same for the phase element and ground element. So earlier we have done the first video. If you can watch also on our first video, we have done this bus coupler here so that you can familiarize or understand how we come at these relay settings from here. Right now we are on this section. Later we will going to discuss how we come up these relay settings from here. So the setting for the seconds or for the time is being established prior of the calculation for the relay setting. So as I discussed earlier on my previous video, on how we arrange or we assign our time setting, I will discuss also to this session. So, how we come up this time setting from here for every section, if you have noticed here on the bottom of our 11 kV switchgear on the bus coupler of building F, we provided here at the lowest part to be 0.35 seconds. So our coordination time interval here that is being used is 250 milliseconds or 0.25 seconds. So from the bottom part, we assign here 0.35. The next, this 4 release here, okay, the outgoing feeder of our 11 kV switchgear building A and the incomers of our on building F have the same time setting and also the same time, the same relay setting for the time over current relay. Our time setting here is being assigned as 0.6 seconds or 0.6 second rather. So here, this is covering the 4 relays from here. The next higher component or relay is being assigned as 0.85 second. Then our incomer here, for example, we will have 2 conditions here. First, I will discuss where the available source of power is in the building B or on the bus A side of 11 kV switchgear at building B. For example, the first condition here, for example, if this one will be available, then the other 3 are not. Okay. So from here, we have here 0.85 seconds, right? Then the next one, our cross tie relays for both building A and building B is being assigned next to 0.85 second, wherein we have 0.25 second coordination time interval will be 1.1 second. We will not be considering this. We'll go directly to the bus coupler of our 11 kV switchgear at building B. Next for 1.1 second is 1.35 second. Then on the upstream, okay, will be 1.6 seconds. So this is the way we coordinate the downstream and upstream relays. The next condition is on the building B. Building B is totally out, and for example, on the building A, this one also is out, and this one is the one which is available. So from here, this will be, since this is 0.85 second, this will be 1.1 second. And also here, our cross tie is being assigned both from building A and building B. So if the power is taken from building A, the direction of power is going towards the right. So here, this is 0.85, right? This will be 0.6 seconds. Since these incomers here are not available, the one will be available only to energize our bus A on our 11 kV switchgear on the building B is the bus coupler only. So this will be at 0.35 seconds. So as I discuss this one again, even I discuss this information with my first video in case you have not watched on my first video. So now let's go to our calculation on how we come up this relay setting from here. So our as I discussed earlier, this will be the outgoing feeder of our building A, which is supplying our building F 11 kV switchgear. The relay of we used on this discussion is F60 and MICOM P143, both from GE and Schneider Electric respectively. Our CT ratio is 800 is to 1 ampere 10 VE 5 P20 for the class. PT 11,000 volts is into 110 volts. Our bus bar rating will be 800 ampere. Our minimum line to line fault is 8,406 ampere. Our 11 kV minimum line to ground fault is 409 ampere. Then the same on our previous video, this relay which is being designed for the outgoing feeder, for the MB cable outgoing feeder, the same relay that we use for our earlier discussion. So we will have 4 relays here, 51, then we have here 51N, 59, and 27. So let's start on our relay 51, the phase over current protection. This is the time phase over current protection. Here, on our first threshold, it is being calculated as there to be set at 120% for the CT and or for the main bus bar. So 120% times 800, that's why we have our first threshold current pickup here to be 960 ampere or 1.2 per unit. 1.2 per unit will just multiply the 960 by our CT ratio, which is 1/800. Here, to calculate on our time dial multiplier, our curve here, our inverse time curve is IEEE very inverse. So this is our equation, and these are our constants from IEEE standard. So here our setting at 0.6 seconds. Why? Because here we need to coordinate this one from downstream, which is 0.35 second. So we will going to use this ground fault, which is 8,406, and our pickup current to be 960. So substituting all this data, we calculated this value for our TDM to be 0.80. That's why we have this value here for our time dial multiplier to be 0.80. So this is for the first threshold. The second threshold will be 105% of the downstream threshold protection setting. Okay, so how we come out this 480? So if you go back here, earlier we have got this value here when we calculate our time over current relay. So this is our setting on our bus coupler. So, this is taken from the downstream bus coupler. So, when we multiply 105% to 480, we have 4,284 ampere, or our pickup current for the second threshold is 4,320 ampere at 5.4 per unit, with a definite time set at 0.6 second. Then, our earth fault protection, or our relay 51N, this threshold is set at 14% rated current of our CT. So we just multiply 0.14 to our CT current. So we have, that's why we have here our pickup earth fault current to be 112 ampere at 0.4 or 0.14 per unit. Same as our phase element. Our definite time setting is 0.6 second. Okay, so for the over voltage, we have here the 59 relay and the 27 relay. So here our threshold is at 115% of the rated voltage. So 115% times our 11 kV on the primary side, on the nominal voltage of our medium voltage. Okay, so our over voltage peak up value is 12,650 volts at 115 per unit, with a definite time set at 2 seconds. So here we need to remember that this has to coordinate also with the downstream. In our downstream, we have the same over voltage setting, but the setting for our time will have to coordinate. So let's check our previous setting for our phase over voltage protection. So I will open the previous file. So from our previous file, we have here 1.75 second. That's why we sit here at 2 seconds. The same, we have the difference is also 250 millisecond. Okay, so for our under voltage protection, or our phase 27 27 relay, our threshold here is 80% of the nominal voltage, which is 11 kV. So our setting here for our under voltage is 8,800 volts at or 0.8 per unit, with a definite time set at 0.35 second. So this time setting also has to be coordinated on our downstream relay. So on our previous calculation, we have at 3.25 second. Here we have at 3.5 second. So here is different, because if you check on our phase over voltage protection, on our downstream, we have here our setting is 2 seconds, right? 2 seconds. Our downstream is 1.75. So we are increasing. But for our phase under voltage, our setting earlier for downstream is 3.25 second. But here on our setting for our upstream is 3 0.5 second. So, okay, so no, there's no such different. Meaning, our setting for our phase over voltage protection and phase under voltage protection has increased by 250 millisecond to coordinate with our downstream relay. So we will have only the same setting for our phase over voltage and phase under voltage, but the setting for our time will have a difference of 250 milliseconds because it has to coordinate with our downstream relay. Thanks for watching.